So welcome everyone to this wonderful session this morning. We are going to have Tim Hudson and Danielle Alcaraz presenting to you about classroom practices that ensure all students succeed. Take it away, Tim. Take it away, Danielle.
Hey, thank you so much, Julie. My name is Tim Hudson. I'll introduce myself briefly in a second. And both Danielle and I are with Dreambox Learning. We're sponsoring this great conference. But importantly, this session is not just a whole Dreambox pitch or anything like that. We'll say a few things here and there at the start just to make sure you know what Dreambox is. But the majority of the content is not really Dreambox specific, so it's not a huge commercial. And I'll turn it over to Danielle to do a little intro, and then I'll basically take it the rest of the session.
Thank you so much, Tim. Good morning, everyone. And thank you so much for coming on a Saturday. We can't thank you enough for all the work that you do for our communities and our students and our educators. So kudos to you, pat on the back. We work with a number of school districts throughout the Bay Area and just honored to be a part of the North Bay Learning Innovation Summit and our work with CUE and Napa Learns. I just can't commend you enough for all the excellence that you have been producing in this time. And we're really excited to share some pedagogy and some thought leadership around classroom practices that ensure all students get it in math. I will be monitoring the chat room. You can also reach me on Twitter at dalcarazOC. And then we'll also include our email at the end, but we're happy to continue the conversation directly one-on-one or in a group format as well. So thank you, Dr. Hudson.
All right. So got 4 slides. In case you're not familiar with Dreambox, we'll tell you what it is in 4 slides and then get to the meat of the session. I'm a former high school math teacher. Not sure what your high school math experience was, but not everyone has a great high school math experience. I became a math curriculum coordinator in suburban St. Louis for the district that I actually went to as a student, which was a lot of fun. I've co-authored a chapter in a book on math intervention. Check it out from NCTM. It's called Reweaving the Tapestry. I don't get any royalties, but there's really good insights in there about this topic. Classrooms Where Children Learn was the name of my chapter. And I've been with Dreambox for almost 10 years now. We are a K-8 online digital math curriculum. We're not a core thing that has 180 days. Instead, we ask for an hour a week. And it improves student achievement in significant ways in a lot of different models. It's self-directed, which has been important for this remote learning time, but in-person, rotation, workshops, and even some whole class capabilities as well. We have 3 different age-appropriate environments for K2, 3, 5, and 6 through 8. Dreambox continually makes assignments and personalizes learning for students. But teachers can also make assignments as well to help kids with specific topics that the teacher and the classroom has need of. This is a short video just showing some of our manipulatives. Our goal is to create experiences understanding mathematics that can only be done in a digital environment. So we're not just replicating or digitizing, or if you're familiar with the SAMR model, right? We're not a substitute, we're an augmentation. Teachers appreciate that we're engaging students with learning mathematics in ways that can't be done without technology. With just an hour a week, independent studies of Dreambox have found students grow 60% more with just an hour a week. Independent studies from Harvard and SRI, and we are the only elementary math software program on evidence for ESSA with a high rating, the highest rating of strong. So we're very proud of our efficacy. Regardless of what benchmark assessment you're using, whether it's NWEA, Renaissance, your Smarter Balanced State test scores, over here on the left, students in grades 4 through 5 in a California district that was 32% ELL. The students doing 5 or more Dreambox lessons a week, which is about an hour, grew 54% more than the students who weren't, than the expectations on the test. So it's all about impact and engaging students in mathematical thinking. And that ends the, hey, here's what Dreambox is about portion. So thank you for, I think I did that in like 2 minutes. So I never like going to conferences and hearing commercials. So we'll get right to it. So 2 of the resources that I've always used throughout my career and just want to recommend at the outset are Understanding by Design and How People Learn, for curriculum, for research, for pedagogy. There's so many nuggets in there that I keep going back to throughout my career that inform the design of our lessons in Dreambox, but also are important for classroom practice. So I'll be referencing some of those today. And really, when we talk about, ensuring all students get it in mathematics, planning backwards is Understanding by Design. Give me a little Zoom hand raise if you're familiar with Understanding by Design or have used it before. Use that little, okay, cool, thanks, Anne. I think Zoom has that little, there we go. Debbie's got the thumbs up, the little emojis, cool, all right. Gosh, Adam Leonard, your screen pick is just too adorable. All right, so they talk about planning backwards, right? You identify your desired results, determine your acceptable evidence, and then plan your learning experiences and instruction. Importantly, it's backwards because a lot of times we do 3-2-1, which is called teach, test, and hope for the best. So we want to be deliberate about how we're designing things, and today's talk is going to take you through some ideas about each of these 3 stages. This question comes up a lot as a math teacher and math leader throughout my career. What are we supposed to do when students don't get it? And that's a fascinating question that we really have to dig into, the it. What is it? So that's the very first thing that we have to start with. What is it? What is our desired result? Now, one of the things that when I was hiring math teachers as a math supervisor, a question that I always asked in the interview, one of my first questions actually, is also a question that I really wish we would ask every graduate right before we hand them their diploma. And that question is like, hey, you've just got done with 13 years of math. What is math? And I would ask this to teachers who wanted to teach math in our district. And the responses I got were all over the place sometimes from teacher applicants. Real quick, type into the chat. What is math? What is math? As you're typing that, my wife always thought that was kind of an unfair question to ask teacher candidates. But if you're going to teach math to our students, I would argue this is the most fair question to ask. That's where it always starts off, right? I have a feeling that most high school graduates would not have a strong answer. We got a lot of problem solving, logic and problem solving, skill for everyday lives. All right. How numbers work, right? Like, yeah, biologists, they're problem solvers too. Engineers, so it's something what's really unique and specific to math. So a lot of times we get answers like, well, it's computation, it's patterns, it's problem solving, shapes, finding X, and X is always in the nice little italicized Times New Roman to be sure. Ooh, math is very convoluted. I like that. We could dig into that. So before I get into how I think we should be defining it, I want to give everybody a little pop quiz. So don't use your cell phone calculator, or I guess you're on your computer maybe too. You don't use your computer calculator, no pencils, just mental math. And when you get the answer, I want you to pop up a little like thumbs up with the Zoom reactions, I think they're called, right? So here we go. Do that math problem real quick. Looking for a little thumbs up when you got it. All right, we're getting some answers. Now I want you to, I'm gonna pause you for a minute because I don't, care about the answer. A calculator could give it to you. Julie, are we able to unmute folks? Can they unmute themselves? I saw Adam, your thumb popped up pretty quick. Do you want to tell us how you solved it, how you thought about it?
They should be able to unmute themselves. Yes. All
right, Adam, you were pretty quick to it. How'd you solve it?
So I treated the first value of 3,998 as 4,000. And then I added it to the other 4,000. So I had 8,000. Then I added the 247. So I had 8,247, and I subtracted the 2 that I added to 3.
There you go. Nice. That's a strategy kind of called, sometimes people say I rounded it to 4,000. Compensation, where you take 2 from one number and move it to the other number. Because yeah, 4,000 is pretty round. That's great. Give me a thumbs up. Raise your hand if that's what you did. All right. Raise your hand if you wish that's what you did. All right. There we go. Anybody out there was like, all right, well, 7 and 8. I know I got a 5 in the ones place, and I better clear my schedule for the next few minutes because we're in for a ride. Right, that it is there, you know, with mathematics, a lot of times we're just taught one way to solve something, but there are better ways to solve them sometimes. And there's not one right way to solve every single problem. And it's not just about right and wrong answers. It's also about how a student is solving it. So there's some kind of, you know, thinking, strategic thinking. Mathematicians are big into efficiency. So here's the definition that I like, and it's from Dr. Eugenia Chang. She wrote, she's a mathematician, written a couple books, The Art of Logic in an Illogical World, and she defined it as the logical study of how logical things work. And when I think about, you know, I'm teaching a lot of geometry in high school. That was the class I taught the most, and we're proving that 2 triangles are congruent. Well, 2 triangles are the most basic shape. 3 sides is the bare minimum you can have. And we do these triangle proofs because it's very narrow. These are logical things. 2 triangles are immutable. They're not changeable. What can you learn about each of them in order to determine if they're the same? But when you apply that to something like sociology or politics, or you say, is the government of this country similar to the government of this country? What makes something a democracy? These sorts of complicated questions, those things are not logical. So if we can't even apply logical thinking to these 2 little triangles that aren't going anywhere, what hope could we possibly have for logically thinking about illogical things? So I really dig this definition. And as an example of how logical things work, this is a video of my oldest son. When we had first moved to Seattle to join Dreambox, I had guinea pigged him on Dreambox when he was a kid. I'm from Missouri. As you may know, Missouri is the show me state. And he was in 1st grade, and he was given this problem in Dreambox. What's 12 times 80? How do you solve it? And here's how he solved it.
Oh, cool. Here's a problem to solve. Type the product in the problem and then click OK.
7, 8, 9, 10 times 80. That's 800. 880. 960.
So that's not how I learned how to do it. 10 times 80 is 800, and then let's add another 80, and let's add another 80. What I love about that, and that's part of the reason I came to Dreambox, is because he wasn't trying to remember what his teacher told him. He wasn't trying to remember the specific steps of the procedure. He was just thinking logically about these numbers. And that's what we want for all students. Here's a story. I was working with a 4th grader when we were building our subtraction algorithm lessons in Dreambox. And this was a 4th grader who was in the gifted program. He was getting A's in math. And I gave him a bunch of borrowing problems. Subtraction problems, some with borrowing, as it were. And he aced it. He was perfect at the procedure, much like I was as a student. And we got done. I was like, thanks, that's all I needed. And he said, you know what? You didn't give me any hard ones. And I said, hard ones? What do you mean hard ones? And he's like, well, hard ones where there's a 0 in the middle of the top number, because we were doing all 3-digit minus 3-digit like this. And I was like, oh, you mean? And I wrote up this problem exactly. And I was like this, and he's like, yes, that is a hard problem. And I was like, can you do that in your head? And he just stared at it and was like, no, I cannot do that in my head. Now I know what he was doing. He was trying to do all the borrowing on his like mental whiteboard, and it's just a mess. There's just way too much to do, but he wasn't looking at the numbers. This is a super easy problem, as you see already. So I was like, why is this hard? And he's like, well, you need to subtract 6 from 1, but you can't do that. So you need to borrow. He's like, you need to go next door to borrow a cup of sugar, but they're not home. So you've got to go 2 doors down to borrow the cup of sugar. And I was like, oh man, this is, so he goes through all this borrowing and he gets 005, and he And he's like, all right, you don't even need those zeros. 5 is the answer. I drew it out on a number line and I was like 1, 2, 3, 4, 5, or doing what Jen said, right? Yeah, just bump both numbers up. Constant difference, another great strategy. He couldn't conceive of that. So I'm wondering if he really should have had an A in his math class, because he wasn't really doing logical thinking about logical things. He was a good rule follower, right? The difference between a cook or a chef sort of thing. One thing that a lot of times people don't get in math is why when you subtract a negative number, do you plus them? Does it become a positive? Why is subtracting negative a positive? Does anybody, like, there's a lot of ways to teach that. One way that I didn't learn, and maybe you didn't either, is because this is an example of logically thinking about logical things. 3 minus 2 is 1. 3 minus 1 is 2. 3 minus 0 is 3. Well, look at this pattern here. If we go 2, 1, 0, and then we add 3 minus negative 1, well, the pattern has to hold 1, 2, 3, 4. It's just a logical extension. If this wasn't the case, the whole number system would blow up. Give me a quick reaction. Raise your hand. Were you taught this way in school about subtracting negatives? I'm seeing a lot of, yeah, Jen, you were? No, you weren't. Right. Why is that? Like this.
No, I was taught the turn it into 2 positives.
Yeah. And
which I don't know why, I just did it.
Right. And it's not like this particular layout, like 5th graders could get this. Like this isn't our, like, why were we not taught this? So thank you all for hopping in the chat to confirm. I keep asking these sort of basic questions about math and how we learn things. And just widespread, not a lot of people had this experience in school learning basic logic when it's just right there and so easy. So, you know, anybody want to share? This is a safe place, right? I mean, it's being recorded, but it's still a safe place. Is there any sorry for the scary clown here. What is an that you didn't get when you were a student? Anybody want to share a story about how you felt and how long you felt that way? How'd you respond? Anybody want to share some personal experience? Yeah, go ahead, Jen.
So I want to say it was my senior year in high school, and I was normally a straight A student, except when it came to math. I had to work really hard for my B pluses, and I was able to pass Algebra 1 and Algebra 2 with no problem, B pluses. But then I had the option to take geometry. And I had, and no offense to PE teachers, but he was the football coach and the wrestling coach and also a geometry teacher. And we just spent all day talking about football and wrestling, and there was no math taught. And I was afraid to lower my GPA by not getting a good grade in his class. And I didn't even need the class. I just wanted to take it. So I ended up dropping it. But I just, like, that's a failure. You know what I mean? Like, I had to drop a class because I wasn't getting it. So I just don't ever want to be that kind of teacher. I don't want kids to feel like they're a failure.
Right. Absolutely. Like, you think about, I think for a while, Home Depot's motto was, you can do it, we can help. That's how our math classroom should be. You can do it is the first thing. Anne typed in the chat, you hated algebra as a child and didn't like it until trig. That's, a lot of times trig, people check out at trig, but that kind of brought you back in, Anne? Nice. More triangles there. Anybody else want to share a story of some time you didn't get something in math?
I have one.
Yeah, Amy, go ahead. Thanks.
It goes all the way back to 2nd grade. And it was right when we started to add large numbers using place value. And I remember sitting there with my chalkboard and chalk and given, for example, something like 296 and then subtracting another 3-digit number. And I was actually writing out 20090 and then my 80 and my 6. And I was trying to solve this. And I remember sitting there with my head just spinning. And one of the classroom assistants, like a paraeducator, had walked up behind me and said, "No, you're doing that wrong," but then didn't offer to explain what I was doing wrong. So that affected moving forward. I mean, we're talking straight through high school, not having that solid understanding of true place value was It was awful, and that haunted me for years. So not a great experience.
Yeah, I'm really sorry that that happened. Like, place value is insanely complicated. It is one of humanity's most brilliant inventions, the Arabic numeral system. But just because it's a brilliant thing humanity invented doesn't mean that it's intuitive to a second grader. It's so complicated, and we don't honor that. You know, we have a lot of expert blind spots, and yeah. Thank you for sharing that, Amy.
Yes.
Yeah, thank you all for typing stuff in the chat. This is great. Okay, so importantly, then the first main thing about math, if kids aren't getting it, we need to be really clear about what the it is, and I guess based on the conversations we just had, also honoring the complexity of what it is. We expect a lot from our students at a young age about numeracy and place value. So now let's talk about determining acceptable evidence, because what we assess students on, defines what they think math is. So if we're going to take what we think math is, they're only going to believe what math is based on what we're grading them on, based on what we're putting in the report card. Like, if I see that someone's Algebra 2 grade is a B, I actually don't assume that means they're very good communicators in mathematics. I kind of assume that they can do a lot of things that Wolfram Alpha or a graphing calculator could do, because so much of Algebra 2 is procedural. I have a 10th grade, actually my son who you saw in that video, he's in 10th grade now, and I'm helping him with like polynomial long division, which is horrific, but that's a conversation for another time. So how do we assess and report when students get it in math? Frequent things that we hear teachers sort of lamenting, even though some students can follow procedures, most still don't understand the big ideas in math, like the kid borrowing a cup of sugar. My students aren't curious in math. They just wait for me to show them what to do. That is a huge one. And side note here, in our program Dreambox, we don't have any video lectures. We engage students in, treating math and the task more like a game. Like, there's no video lectures in Super Mario Brothers or Angry Birds, right? It's immersive. You get in there, we give you hints and scaffolds, but a lot of times, especially older students, are like, Dreambox didn't tell me what to do, so I don't know what to do. And we cannot cultivate that learned helplessness. That's a problem. We need kids to have agency and realize that the act of mathematics is not a sit and get experience. It's a think and do experience. This is a tweet from a couple years ago at a math conference. How do you balance your desire for deeper math and the student need for basic skills? Sometimes I feel like I could do basics forever and still not make progress. So this is something that a lot of times when kids aren't getting it, we think that we should spend our time on basic skills. And that's the wrong place to spend our time. What are the basic skills in math, for example? That 4th grader I was telling you about who borrowed a cup of sugar, he had the basic skills down pretty well, but he missed all the big ideas. Like, we were assessing and celebrating the wrong things. So an important framework that Authentic Education, Grant Wiggins, one of the authors of Understanding by Design, they talk about is there's 3 different kinds of learning outcomes: A, M, and T, the acquisition of knowledge and skills, the meaning making, and the transfer. Now, this isn't an order. It's not like you can't do one before the other. Like, that's not the point. That's just a framework. That's not a sequence. And this is the information, the facts, the procedures. When people say you can learn anything online, I think that really means you can acquire a lot of knowledge and skills online. There's a lot of this out there on the internet. I just got done remodeling a bathroom. Spent a lot of times on YouTube watching people do things and making it look super easy. It's not easy. And our kids probably feel that way sometimes if they're looking for math help online for polynomial long division or whatever. But the meaning making, that's the concepts, the ideas, the context, the situations. But then the transfer is all about what you do independently in unfamiliar situations. And when we say basic skills, people typically mean the acquisition of knowledge and skills. That's not really how to help students get it, because there are bigger ideas that help your skills, actually. So as an example, if we taught kids to drive a manual transmission the same way we teach kids math, it would probably look like this. On Monday, we're going to move the stick shift. On Tuesday, we're going to pump the clutch. On Wednesday, that's gas and brake day. Thursday, that's steering day. And Friday, we're going to go out on the road and things are not going to work. Right? Like, it's not as though the acquisition of a bunch of disconnected skills is going to lead to the transfer that we need. It's not going to happen. So we have to teach kids things differently. And it might feel good to have a minor success, be like, okay, my students finally got how to move the stick shift. But that's a short-lived gain. It's you won the battle, but you're never going to win the war because everything has to come together. It's kind of like, you ever seen a student, okay, 12 minus 7, we're going to go ahead and borrow the 1, and I just have to figure out what 12 minus 7 is. Like, it doesn't work. I used to have, one of my favorite things to do was give parent talks, and parents would say things like, look, you just need to give kids the basics so they have something to fall back on, like long division. And I would put this problem up for them. And I would say, okay, use long division there. And they're like, well, 51 won't go into 4, 51 won't go into 48. Okay, good, 51 will go into 486. Like, what are you gonna do now? What you fall back on is not some algorithm. What you fall back on is your number sense. This problem right here, 12 divided by 300, long division is probably a bad way to go about doing that. If you look at both of these numbers and you think, oh my gosh, they're both divisible by 3. 300 divided by 3 is 100. 12 divided by 3 is 4. Oh my gosh, 100 divided by 4 is 25. That's super easy. But if you look at it like it's long division, it's not going to be good. So when we're assessing things to make sure students get it, we need to be assessing different things. And I'll share some examples in a second. Side note, if we're serious about speed and efficiency, was anybody taught short division? Probably not. It's a thing. I only learned about it like 10 years ago. I'm really upset with myself as a student for not having asked that question when the teacher's like, we're going to do long division today. I'd be like, when does short division happen? Like, we want kids to ask those questions because we take things for granted. All right. So the big idea here. Oh, yeah, Jen, area model's super good. Oh, side note on the area model. Some of you might not know this symbol here for long division was originally invented to show you, oh, this is actually a rectangle whose area is 486 and one side length is 51. Find the other side length, the area model. A lot of people don't know that's where that symbol comes from, but it seems like we should have been told that because that would have made things super helpful. So meaning and transfer will always outweigh a bunch of disconnected skills. That's kind of a fact. So let's compare and contrast what the sort of it is that we want to be assessing for. We want kids to know their 12 by 12 facts or whatever, like, sure. Do you need to memorize them? I don't think so. Do you need to know them from memory? Probably, but just because you need to know them from memory doesn't mean you have to memorize them. That's a separate talk for another time. But we have failed if someone needs a calculator to do 13 times 7 mentally. Because if you know 12 times 7, you should be able to add another 7. So are we only assessing up to 12 by 12 and not going beyond that to that transfer piece? Too often we are. Do we want kids to know how to calculate the slope of a line? Y'all remember y1 minus y2 over x1 minus x2. It's all coming back to you now, Celine Dion. Sure, but do we want to be able to estimate rates of change in different kinds of situations without having to grab a pencil all the time? Yeah, we want them to be able to look at a graph and kind of have a sense for how big the slope is. Mean, median, and mode. We want kids to compute those, absolutely. But most importantly, they need to know which one is best for the situation. And if we're not giving them a situation, then why are we even having them calculate them? We'll talk about that a little more in just a second. Let me pause there. You can type in the chat, or if anybody wants to, get your voice in here, it's all good. My question is, do we think our students in math know that we want all of these outcomes? I see some head shaking.
This is Julie speaking. I think we do. Many of us teachers, of course, want our kids to make meaning and transfer it next and have that acquisition. That's all about that superficial and then the deeper and the application aspect. I think we all really do, and we try to communicate that to our students that this is what we want for them to happen in their personal lives. But I don't know if they can actually demonstrate it, and I think that that's where part of the struggle is. I know that when the kids are using Dreambox, at least my kids, I'm not saying everybody's, but some of my kids have told me, Mrs. Mary Houston, I try to use the tips and it just repeats the same thing, and if I don't get it the first 3 times, how am I going to get it the 4th time? And that's a 4th grade student that's talking to me. So
Yeah.
like, oh, okay, let's talk about it in class, but wow, there is some challenge
Yeah.
in this.
Yeah, absolutely. And yeah, for, whether you're a teacher coming alongside and you want to give what's the just right nudge, right level of feedback, right analysis of their work to help them, those learning moments, it's difficult. And yeah, let's see, Jen, you try to put your learning goals on your slides before each math lesson, right? We want to remind kids. And then also the whole point of this section is let's make sure we're assessing it, right? Let's make sure that we're not just testing the skills. Yep, some real life situations, giving them some context that makes sense. I feel like if our kids really love Photomath, if you're familiar with this app, it means they don't know we want more than just the skills, I think. Like I mentioned Wolfram Alpha before. It's been around for 10 years. This is amazing. If you type in, I have 2 cookies, you give me 3 cookies, how many cookies do I have? The answer it gives you is a full sentence. It says the result, I have 5 cookies. It talks to you like it's a kid. It gives you an equation. It draws you a picture. And I'm thinking to myself, should Wolfram Alpha get an A? Right? Like they went above and beyond what a kindergartner could do with this problem. Or exactly what we're asking a kindergartner to do. So helpful bit, if you're a math teacher, given some math tests, if Wolfram Alpha can get an A on your test, I would say it's not a good test. It's only testing the skills part and not enough of the meaning part that makes the act of being human like important to this whole task. Mathematics is a human endeavor. Yeah, Dr. Newell mentioning math everywhere. It needs to be fun. That's true. Computers do these things well with the acquisition, but the meaning and the transfer, these are the things that make math worthwhile. But I think too often, even if we want all of these, Julie, as you mentioned, as teachers, we definitely want all these outcomes. I feel like our tests typically skew towards the acquisition piece. And that's going to make it harder for kids to big picture get it in math. So yeah, human intelligence, that's where I place my bets all day, every day. These are amazing technologies. Don't get me wrong. They have a place, but we need to build our curriculum assuming what humans are doing. So if most math tests are assessing too much of the wrong thing, that's kind of what I'm positing, and most grading systems too often report the wrong things. And as an example, if you're familiar with XKCD, he's got a webcomic, a real sciencey math kind of guy. He talks about this, like if we're averaging things, like 4 reviews for this app about the tornado guard that plays a loud alert sound when there's a tornado warning for your area. The first reviewer, 5 stars, good UI, many alert choices. 5 stars, running great, no crashes. 5 stars, I like how you can set multiple locations. 1 star, app did not warn me about tornado. Right? Like we can't give that 4 stars based on these 4 reviews. This is the problem with averaging. And there's a physics teacher in New York, Frank Noskesi, who pointed out a couple years ago, this is like if our grade, we give kids a B, I do all my homework, I participate in class, I organize my binder. I still don't know anything, right? So in math, sometimes if kids are getting it, make sure that your grades are reflecting actual mathematics and what the it is instead of other things that are not really mathematical related. So that's how we get a lot of low achievement. If we're assessing the wrong things and reporting the wrong things, making kids think math isn't what it is. One of the things we did in my Algebra 1 program when I was a math coordinator is we built rubrics for everything to get away from percentages. So like our Missouri State Standard was apply mean, median, and mode to solve problems and make predictions. What we did was we were like, you know what, that's a developing level, but the novice level would be just computing them. Microsoft Excel can do this. But the proficient, what we need from students is to justify the most appropriate statistical measures. It's not just about computing them and solving problems. You got to tell me which one's the best. And then the expert level, what we would actually do on our tests is we would give kids problems from each of these categories. And the expert problems, which students had to try, we would introduce something new. We would say, you know, hey, you've learned about mean, median, and mode. Now here's this new thing. And there's several different ones that are pretty simple. Like one is called the truncated mean, where you take all the numbers, you cut off the highest value and the lowest value and just find the mean of what's left. Maybe in some situations, that's a better measure of central tendency. But the key was to engage students with something they'd never seen before, but was like a near transfer kind of piece. And that helped spur their critical thinking. And Julie, to your question earlier, like about we're sometimes uncertain about what students might be capable of if we put them in these situations. This really helped set that expectation. Hey, on every test, there's going to be one little piece that we think you can do. So show me what you can do, right? And get some creativity and really set that expectation. And so at the end of the semester, we would have, you know, these were the rubrics for all of the different standards that we had to touch. And kids would be, you know, at developing, proficient, expert in these different ones. And the cool thing was, if a student left our school and had to transfer, we could send this assessment with narrative, with actual like rich proficiency information to their next school. I would have loved to have gotten this whenever a new student came into class. Don't just give me, well, they have a B+, it was 86%. What does that mean? So to help students get it in math, more very specifically defining what the it is and sort of where you grow to is a really powerful and important thing. When you change the assessment and reporting system, you change the conversation with students, because we previously had juniors in honors pre-calc one morning came into our class, one of our department leaders class, and is like, hey, it's about time for the finals. I have an 89.4%. Can I do some extra work to get an 89.5? So it'll round up to an A, maybe bring in a box of Kleenex. I don't know. How's your Kleenex supply? Like they're talking about points. They're talking about point grubbing. They're not talking about mathematics. But when we implemented those rubrics for our freshmen, all of our freshmen in the district throughout Algebra 1, a freshman actually came in right after that junior and said, hey, I know I can compute these things. I have no clue how to decide which one's best. Can you help me with that? This is where we want to be, where kids are coming to us and we're changing the conversation. It's not about my percentages and my points. It's about the mathematics and how I can grow and to be able to see that in how I'm being graded. So last piece, the practices that ensure all students get it. So we've talked about the goals, the assessment. An important thing here is that in understanding by design, they separate out learning experiences and instruction. And there's a lot to these definitions that we need to double click on in order to understand how to help all students get it. Real quick, type in the chat. Define instruction. A lot of school districts have a curriculum and instruction department. You know, maybe you're an instructional leader. What does instruction mean? Side note, Pat, that grading system is way more equitable. I give a talk at NCTM conferences usually around that. It's all about equity for sure. All right, in the interest of time, ooh, there we go. Cool, cool. All right, I'm gonna give you the dictionary definition. Here are the 6 different definitions, and the things that pop out to me: knowledge imparted, orders or directions, furnishing with authoritative directions, commands given to carry out operations. That kind of feels like how my math classes were when I was growing up as a student. It's a passive thing. Someone's giving you something. Someone's telling you something. Yeah, Penelope, a set of directions that are given. Open up the instructions to assemble my IKEA cabinet or whatever. Inherently in this definition is a passiveness. There's not a lot of sense making necessarily. And what it leads to is experiences like this. I'm gonna show you this video. You can find it on YouTube. Kid Snippets is a group of folks where they have, Shannon, you see you nodding. They have kids act out scenes. Think like Blind Date is one, Job Interview is one, and they got this one called Math Class. And then they have adult actors. They dub the kids' voices over the adult actors, and the adult actors act out the scene. So here, check this out.
I think it's already starting. Okay, here's your homework. First let me tell you the directions. What's 4 take away 5? 1, 2, 3, 4, 5, 6. Take away. What's 6 take away 1? 1. No, you take away, so you take away 1 out of 6. How much does it equal? What's 10 minus 1? I don't know. 1, 2, 3, 4, 5, 6. 6, 7, 8, 9, 10. Nope. Take away 1. How much is this? 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8. And one more. And add 1 more. How many does it equal? 1, 2, 3, 4, 5, 6, 7, 8. 1. It makes 9. See how you take away? You take away 1 and it equals 1. Do you get it now? Yes.
Man, oh man, I can watch that all day long. So that's how math class feels. Anybody ever waved the finger to try to help kids understand, right? This is, that's how instruction feels to kids. You're being told that you're not getting it. And no matter how slower or louder I talk, it's not gonna help. And similarly with like online videos, it's like pausing and rewinding can only take us so far. Like it's the 21st century equivalent of talking slower and louder. Now, by contrast, the learning experience, I think John Dewey 100 years ago had the best definition. You need a genuine situation where a genuine problem develops, where kids have to seek information, make observations, and solutions occur to them. We want kids to feel like math class is a place where things occur to you, where you have ahas, instead of a place where you just get answers to questions you've never asked. That's how you get the thinking to go on and an opportunity to test those ideas. So those are the kinds of conditions that we need to create in class. One example, Kathy Fosno has a set of math curriculum called Context for Learning. And she's on our board, and like this simple example of there's 4 different vehicles going on a field trip, and a bunch of sub sandwiches are given to each vehicle. So 4 kids get 3 subs and 8 kids get 7 subs, 5, like kids immediately start wondering, oh, is that fair? Is everybody getting equal numbers of sandwiches? And you use this to introduce the idea of fractions, and kids invent fractions in a super amazing way, kind of like how the ancient Egyptians did. Again, that's another talk. But you give them this situation as a learning experience. And over the course of 5 days, as they do this project, kids multiply, divide, add, and subtract fractions like all at the same time. We're bringing those driving skills together. It's not just let's add fractions on one day like the stick shift. And I'll show you one example of how we do this in Dreambox, because I haven't really shown a specific lesson. But when learning angle measurement, a whole circle is 360 degrees. Kids don't know that. They have no way to know that. But we invented a game where instead of having a video lecture and just telling them a circle is 360 degrees, we say, help this spider build a web and enter a number that's going to rotate the web maker exactly one full rotation. Kids always type 100. They're like, that's an important number. You know, they're in 3rd or 4th grade now, and 100 doesn't spin at one full circle. So they're like, I don't know, 200 maybe. And that looks even weirder. So then they're like, I don't know, 4,000, whatever. We will show kids what 4,000 degrees looks like because there's no reason not to. Let them explore. Let them take this situation. They can even type negative 360. They don't, but they could because negative rotation is a thing. So in Dreambox, we want to create these conditions where it's a reasonable situation. Kids can access it. There's a low floor to entry and they can think about it. And it's kind of fun. So with that, the conclusion of my talk is really, if we want all students to get it in math, we need more learning experiences and less instruction. Create those conditions where kids are thinking for themselves and make sure the outcomes are super clear and way beyond just the basics. So let me pause. Thank you. We all have time for some questions.
Yes, at this point now, it's about 3 minutes before the end of the at the end of this session. And so we'd love for you to ask any questions you have. In the meantime, I'm going to put into the chat box our survey that we are requesting for our audience to fill out for this session specifically. What did you like? What was challenging and what would you like to see differently maybe? So it is really good for our entire summit, given the fact that this is the first time that we're doing it with over about 450 participants. So thank you all so much for being here. We're really thankful to Tim Hudson, as well as to Danielle Alcaraz for being here and presenting not specifically about Dreambox, but how to have our students thinking about math.
I have a question.
Yeah, go ahead, Em.
What was the process with creating the rubric? Because for me, that's like one of the biggest things of like where to start. And so was the novice, and then I forgot what the next category was, but was that the developing? That was set, like where did you set the standard that you're trying to get with proficient? Like no matter what the proficiency is, the exact standard, and then you worked what expert looks like and then back down?
Yeah, basically. So you're seeing the rubric slide again? Should be being shared right now? Yeah.
Yeah, I see it.
So you see these little codes, N1A, A1D. So those are the state standards. We kind of had to start there. And we broke the standards generally into their own line items, so to speak. In some cases, like you see here, A3A and A1C, these were the Missouri state standards. We were like, you know what? Those are really on the same continuum. So there was a little negotiating there. But yeah, in general, we took the state standards and then decided whether we thought that was novice, developing, proficient. And that was just sort of a process where, you know, with this one, D3A, make and justify predictions when given a graph, we kind of thought that was the most basic level. You know, here when given a table, like there was a whole modeling strand. So that was a process. A big summer workshop with about 12 teachers from each of our 4 traditional high schools. And yeah, working through a lot of it. Does that help?
Yes,
Okay.
It does. Thank you.
Cool. Yeah. There are a few slides I did not get to that are in the presentation folder, which Jen, I think you said you found. It's on Shed. Shoot, I never pronounced that right.
I think it's Sked. I mean, like schedule.
I would, yeah, that's good. That's good. Any other thoughts or questions?
All righty, we're going to be wrapping up in about 30 seconds if anyone else has anything to say. And I'm wondering if some people thought that there was going to be more conversation about the actual usage of Dreambox. And that's just a think aloud, like, is that a possibility? But I think the way that you addressed it in regards to how it seems like Dreambox was created, which is for the more experience rather than us telling them what to do, and then for them to discover how to use their critical thinking skills to solve the problem, was a wonderful way of showing us how Dreambox is built in that thinking, on that thinking.
Yeah, this is our guiding principle. You can't put things into a mind. You have to empower a mind to generate thoughts. That's how kids are going to get it in math. They have to be doing the thinking. Danielle, do you have anything you want to add here at the end?
Yeah, I was just going to say, if anyone does have specific questions related to Dreambox, I just put my email in the chat. So feel free to contact us if there's some particulars that we can answer for you. But thanks for having us. We really appreciate it.
Thank you so
All
much.
right. Thank you so much, everyone. Please make sure that you go back to the regular class or regular session. It's called the tasting room. And then it will be lunchtime after that with networking at 12:20. And there will be breakout rooms available for you. So thank you. And then our first session, or rather our first session for the afternoon, will be at 1 o'clock. Take care, everyone. And thank you again, Tim and Danielle.
Thank you
Bye
so
for now.
much. Bye-bye.
Thanks.